And launch the first presentation. You got it up, and then go live, record. We are recording. Okay. Well, good morning, everybody. I noticed some folks must have gone to the party last night. We're going to go ahead and kick off. This particular session is a review of hemp farming challenges and auxiliary opportunities, and you'll see what I mean by that when Steve starts talking. Steve Edmonds, who is the CEO of Native Hemp Solutions and Hemp for Water, is going to moderate this session. Many of you know Steve. He has been instrumental to me in this whole arena because he knows more about hemp than just about a lot of people that I have talked to. So, sir, I'm going to turn it over to you and let you run with it.
All right. Well, thank you very much, Gene. Nice brief introduction that I hope I live up to. As Gene said, my name is Steve Edmonds. I've been in advocacy in industrial hemp, or advocating for industrial hemp, since, I don't know, the first speech I gave on it was in 1992. So it's been a minute. I've been involved with a lot of the efforts to bring the industry to this state, and I have to be honest, I'm getting a little concerned. And the reason why I'm getting a little concerned is I see a lot of indications that we're just not starting. We're not getting there. We're not coming out of the gate for some reason, and we need to come out of the gate. And there's a lot of really huge positive reasons for us to come out of the gate, especially in this state. We have way more available land than most other states. We have a much better temperature and climate than most other states. We have better precipitation than most other states. Every cultivar that I've been told won't grow here grows just fine. We are in an advantageous position that we are walking away from for some reason, and I'm trying to figure that out because I've been understanding the advantages and the opportunities for this plant for getting close to 30 years now, and I'm trying to understand why you guys don't get it. And I know that's not you guys. It's the rest of everybody else that's not here. And that seems to be the problem. And I'm hoping that maybe you all can help me. And the way we do that is talk. The way that we do that is we go back to our communities, we go back to our organizations, we go back to our groups that aren't affiliated with cannabis or hemp, and we talk. And we talk about how this plant could be an opportunity for all of our economic futures. Not only that, but I think it's an opportunity for our environmental futures too, which is the primary reason why I'm in all of this. So with that, we're going to hear today from a few different people on the panel. A couple of them are associated with myself and Hemp for Water, and a couple of them I have had just the pleasure of meeting today. So we're going to have some new information and some old information, and hopefully some future information. And with that, I'd like to introduce Kat, as she introduced herself to me, and let her tell you her place and position in this world of opportunity.
Make sure I know how to work this. Awesome. Okay. Well, good morning, everybody. Thanks for being here early and being involved in everything we're doing for hemp in Florida. I am Kathryn Arnold, but I do go by Kat, so you're more than welcome to call me that. And I am from Florida Panhandle Hemp. We are a farm in the Panhandle of Florida, Gulf County. And we are a coastal growing facility that's 5 miles north of the Gulf of Mexico, directly on Intercoastal Waterway. We are a University of Florida pilot project. We've been working with the University of Florida since 2020 when the pilot project licensure came out, and they have been an immense help with bringing hemp to Florida, and I am very proud to be a pilot project partner with them. They are awesome guys. All the extension officers have done an amazing job on this project, and I will talk about that as well as some of our commercial avenues that we've been working on for the past couple of years as well. Whoops, I went back. Anyways, that worked out because I am talking today about mitigating negative effects of a humid subtropical climate and soils here in Florida. It has been one of our biggest challenges. Again, on the research side of things at the University of Florida, we are actually have been more working on permaculture prospects and organic farming with the hemp, as well as some genetic research. But we've found in the past couple of years that we have had to deal with a few issues that have risen from the tropical environment that we're working in, including a few hurricanes. As Ethan mentioned yesterday, our first crop we replanted twice, and both times we got rained out pretty hard. So we have figured out how to overcome those obstacles in the past few years, and now we have become very successful in growing hemp in Florida, and really proud to share that, yes, it is doable, and we're ready for the go-ahead as soon as we get processing in the area. So I am, again, in Gulf County. The big red blob is where our farm is located. We're located 10 miles due north of where Hurricane Michael, if anybody is familiar, made landfall in 2018. Our farm was timber at the time, as were many farms in the area. At that time, after Hurricane Michael, our area was 90% devastated. That included 500 million trees uprooted and a loss of 90 million tons of standing timber. So that was a huge economic loss for our area. So we decided to look into alternative methods of agricultural renewal in the area, and in hopes of bringing some economic growth. And then, of course, a couple years later, we decided to go into the hemp, and thought that it would be a viable resource for the area. We'll see how that, oh shoot, let me go back. Okay, that's it. Okay, so I'm going to go into our seasons and what our harvests have looked like in the past 3 years, and then also including some of the things we did to mitigate all of the tropical storms that did come through in the past couple of years. So as you can see, July 15th, we actually got some rainfall that was good for the area. I know it looks a little scary in the picture, but we were able to plant 2 days later. We planted a Maverick and a cherry wine strain. As you can see, July 23rd through August 4th, we had a substantial stand rate of, I would say, 98% or so. We had a great stand rate. They were direct seeded. In our trial, we did not do a higher bed for those two of July 23rd and August 4th. But then, as you can see, in August 18th, we were starting to get quite a bit of rain at that point. We were hardly using irrigation. So we mounded up the beds a little bit higher. And I do have to say that has helped more than anything, is just having our land higher up. So we've been doing a lot of work on developing the property and increasing the height of the soil and the slopes. And then, of course, August 27th rained us out. Those plants did not live. In the picture, you can see, I think I have a pointer on here too. Right here, this is actually a part of the field, and it was substantially underwater. And so what we did was we put in a dual pump system. So this was our spring-fed pond that we use as irrigation. And then we reversed the pump, and we were able to pump that water out of the field. And having something like that in place, we were able to get that water off the field very quickly, and it made a huge difference. Because we planted so late this year and the plants were very small, they did not do well. But as I'll show you the next year in 2021, we didn't have a problem because we had the pumping in place. And of course, we raised the beds even higher. So just being able to get that water off the field as quickly as possible if you do have a torrential downpour was big. And so then we replanted September 4th. As you can see, compared to August 18th, we went even higher. So we just kept going up. And we actually, our mounder had a ditching attachment. So on either side of the mound, we had ditches in place to where, and we also re-sloped the field. So we were able to re-slope the field and add ditches to the edges. So we had the ditches running down, and of course we had drip irrigation that we didn't necessarily need this time of year, but it was in place in case we did. And then just ran all of that water down those ditches into a bigger retention ditch at the back, and flooded that back into intercoastal. Of course, a question may be about fertilization and how, your best management practices of keeping that fertilization from not entering your waterways with all of the water. And what we did, again, we are organic agriculture, so we weren't able to use the fertigation that we had planned on anyways, so we amended the soil with organic compost and heavy loads of topsoil. So that also raised our land on the plot and then gave us the nutrients that we needed to grow. It made it very easy, not super cost effective on the front side of things, but we found that now that it's on the field and all of our soils have been tested, they stay pretty steady, and we are very happy with the effects of that. So after September 14th, then we go to September 16th, Hurricane Sally came through. And this is also the edge of the field right here, completely underwater again. That receded rather quickly, but it was late in the year, so we decided for that year that we were not planting again. Okay, pause a minute. Okay, so 2021 rolls around. We had a pretty good crop this year. We established some stuff on the field that needed to be worked out for the rain and irrigation. We did start the seeds inside this year, or in 2021. So we started them inside. Those are about 3 weeks in that picture. So they were looking good. They were super steady. We didn't even have much problem once we transplanted them in the field. There was no shock involved, anything like that. One thing that did mitigate that was, as you can see, April 20th, these were also started indoors and then moved to a greenhouse. And as I was talking to someone yesterday, we call it a greenhouse, but it doesn't have sides. And that works really well for us. It's more cost effective. And it's mitigating the rain. You do have to be careful about the lighting at night for pest reasons. But this early in the year, when we actually needed them, we did not have an issue. So we got the breeze, we got the flow of things, and it didn't get super hot in there. And we have yet to put sides. So that has worked very, very well for us with the supplemental lighting. So we took them from indoors, put them in the greenhouse, and then transplanted them onto the field. And that was the easiest way for us to mitigate any effects of anything tropical coming through. Even earlier in the year, I know in 2021, April this year has been pretty hot and not as rainy, but April last year was super, super rainy. We had a lot of rain. So this helped get our stand rate to stay. And we had no issues once we planted into the field, as you can see here. And then, of course, we've got, I'm pointing the wrong way. Of course, we've got the plants here. And I can't, that's June 26th. So June 26th of last year, we had a great stand rate on the field. They were green, they looked good, no issues. We were using, again, minimal fertigation, and mainly just that heavy topsoil with a chicken manure compost mix in it. August 9th here, still doing well, looking good. They were about 4 foot at that point. So really looking good. We then got Tropical Storm Fred, and I believe Fred was a direct hit. The eye went directly over the farm. So we did have some significant damage, or I wouldn't even say significant damage. We did have some damage. We were prepared. We had the pumping system in place, and then we also, because we typically start to see the beginning of flower the first week of August. So right here is probably the very first week of flower. And so the bud structure was starting by the time Tropical Storm Fred came through. We did have to go through the field and stake up some of the heavier branches. I'll show you in a picture coming up on one of the slides where we actually took fishing line and ran stakes down and ran the fishing line through the stakes. And it is a lot of manual labor, does go into having to do something like that, but it did save our plants. So again, we're on a smaller scale. We are just an acre right now. So it was doable to be able to run that fishing line, and it was worthwhile. We did have to harvest some of the plants right after Tropical Storm Fred, so we didn't get, which again, we are doing more research on the industrial side of things. We were looking to see what the flowering process would do outdoor sun-grown, since the previous year we had the washout. But we were okay harvesting after Tropical Storm Fred. Our plants were big enough because we had started them indoors and started earlier. So it was no big deal. We harvested about 25% after Tropical Storm Fred. And then we did good. We got all the water off the field. Like I said again, the flower structure was coming back. Even in this picture, you can see how they were starting to yellow out. We had a little bit of problem with root rot on some of the plants after that, approximately 10% maximum. We started to see some root rot in, and as well as fire ants after Tropical Storm Fred. So we did mitigate all of that. We got it all under control. And then unfortunately, we had our final harvest after Hurricane Ida in August 30th. So we're seeing a trend of 2 hurricanes a year. But we actually did great. We were able to harvest everything. Other than about that 10% that got the root rot in it, a little bit of mold as well after both the hurricanes. But we harvested 90%. And they were large enough to get a decent yield out of that. So we did quite well. Again, with preparing and making sure a couple weeks in advance, before those storms, before hurricane season was even thought of, we had a plan in place. And I do highly, highly recommend have a plan in place. have some people you can call on, have a crew ready in case you do need to harvest early and or prepare for those for a storm to come through. Absolutely. It was very worthwhile. Okay. Okay, I'm gonna get back. So, before we get to can we just skip hurricane season, we decided this year to do a winter season crop. We did do a trial with autoflower, which worked very well, much more stable. And then we did a trial with supplemental lighting. They turned out very well in both respects. I did find that if we could work on, and this is what we will be focusing on, is some autoflower genetics that grow bigger and maybe for a longer period of time so we can harvest some bigger plants, but these autoflower, whoops, let me go back. The autoflower right here, they looked great, they smell great for flower purposes. Again, unfortunately, we're not quite there with the industrial side of things, but we have had great luck with the flower and selling that into the hemp stores, CBD stores, things like that. It did great. I would say these plants were 3 foot, 2 to 3 foot. So not huge, about a foot in width. So not super big. They do really well in a sea of green style, especially if you're not worried about the summer tropical storm effects. You're able to fertilize, you're able to irrigate, you're able to control things so much better in the winter. And because our genetics are coming from cooler weather climates, we did not have a problem whatsoever. And we are in North Florida, so we're as cold as you can get in this area. So we did not have an issue. We didn't have to mitigate one thing to deal with the cold weather. The plants actually seemed to do quite well. Again, we did start them inside on January 30th. We did transfer them outdoors. And we actually didn't even, because of the autoflower, we didn't on these even put them in the greenhouse. The ones we did put in the greenhouse were for the supplemental lighting for the day sensitive varieties. And those haven't quite been completed yet. They're still under lights. We're gonna see how big we can get those. But the autoflower worked really well, and the winter season we find to work way better for the hemp. So yes, we can skip hurricane season. The pros of that would be that we can decrease potential for root rot, pests, structural damage from heavy winds, rainstorms, and high temperatures. It heavily decreases the chance of a catastrophic harvest failure, and of course increases yields and plant health. The cons of that is there is a higher initial cost. You are buying more seeds if you're doing an autoflower variety. You usually do need more land for that as well because your plants aren't getting as tall, they're not getting as big. And then also if you're doing the supplemental lighting and things like that. And then you are shortening your growing season. Because of course, let me go to the next one. I've heard a lot of talk about, yes, Florida does have year-round production potential, but from what we have gathered on our 3 seasons, our winter season was significantly easier and better, and our flower was better. Our plant structure all around was better. So, in our opinion, starting at the end of hurricane season and moving through April is a much better season, and we get higher quality, and we're not dealing with a lot of those effects of hurricane season. And it balanced out to where, you know, we are able to get much higher yields in the winter. And so it didn't make sense to grow and try to mitigate the effects of hurricane season. You can do it, we did it, and we were successful, but it was hard. and you definitely have to have those plans in place. And of course, the winter was just a little more steady and even keel. Let's see. And so this is, I was just going to touch on crop insurance for hemp producers. We have not gotten that for our crop so far, but there are plans in place through the USDA. I do know that you can get NAP insurance, which is the non-insured crop disaster assistance program. You can reach out to your local USDA office if that is something that you are interested in, and they can help you through that process. And it fluctuates and it depends. We've called and they've had it, and we've called and they knew nothing about it. So depending on who you talk to and what they have available at that particular time, but I have been told that is something that we are able to get as hemp producers. What is it?
You're under 2.
Oh, thank you. This is my last slide. And another thing I wanted to touch on, once industrial hemp is able to have a processor in the area and we can do more, one of our research ideas that we think would do very well is a cups system. If anybody's heard of that, they do orange groves that way in citrus here in Florida under the protective screens. And we have talked to some of the producers of these screens and their ideas of it mitigating the pests, of course, and also we did notice that it dispersed the rain better as well. So that would be something in the future that we are looking into on the research side of things for a larger crop. And then again, I'm Kathryn Arnold. This is the end of my presentation. If you have any questions on any of the disaster preparation and recovery services that we can help you with, please reach out.
Thank you, Kat. We're going to have a period at the end of all the presentations for a little question and answer. So if you have a question for Kat, just hold that and we'll get to it at the end of all the presentations. So I think that I'm actually up next with Hemp for Water. For those of you that don't know what Hemp for Water is, we're an idea that started back in 2013, and we officially incorporated as a 501c3 Florida nonprofit in 2019. We ready for the? Great. So basically, when we're dealing with the Florida ecology or the Florida hydrological system, we have a lot of unique challenges. One of those challenges is that we have one of the 3 rivers in the world that runs opposite of the equator. It's the St. Johns River. The other major challenge is that we have one of the largest lakes in the country, the 10th largest lake in Lake Okeechobee of 440,000 acres. And from there, the final challenge is that we have a system that is built for 4 million people that is servicing almost 22 million people. And we deal with a wide variety of environmental situations. So basically, we're going from drought to deluge on an 8 to 10 year cycle within the state of Florida. And Hemp for Water comes more into play when we're in the deluge cycles, because the deluge cycles means that we're getting an extra amount of rainfall, and that extra amount of rainfall has to go somewhere. And typically the way that it works nowadays is that for the largest lake in the state, it's fed by 2 northern basins and 2 adjacent basins that feed into the lake. It fills up to a certain amount, and the U.S. Army Corps of Engineers decides that for flood control, it is going to discharge out of the St. Lucie River, and that's a picture of this, by the way, and the Caloosahatchee River on the west coast. And what we end up with is an incredible amount of fresh water, and even if it was just fresh water with nothing else in it, we would have issues. But it's not clean fresh water. It is full of all sorts of things, including an exorbitant amount of nitrogen and phosphorus. Now, nitrogen and phosphorus are nutrients that we're all aware of, and in fact, they're needed nutrients in almost all of our life cycles and ecosystems. But it's like anything else in life, it's the excess of nitrogen and phosphorus that we have to deal with. And what you see here is a typical picture of any given summer from 2013 on during the right season. That bright green is not photoshopped. That is the result of what we call blue-green algae. There's not very much blue in it. It's usually bright green most of the time, and it's kind of smoky looking if you look down in the water. It's really freaky if you get close to it. I don't recommend getting close to it because it does emit toxic fumes that are created by a cyanobacteria. And since I've been looking at the problem, it's on record that at least once a year somebody dies from complications from these toxic fumes. Several people are hospitalized, and some of them to extraordinarily critical situations. So it's an issue. Not only is it an issue for human health and involvement, but we live in Florida. We recreate in Florida. We rely on something called ecotourism in Florida. And the 2 areas that I'm talking about on the east coast, the Treasure Coast, on the west coast, the Caloosahatchee River outfall area, you're looking at, for 2013 alone, the last summer, it was somewhere around $3 billion for the East Coast and $2 billion for the West Coast, and economic loss and revenue from not being able to use the water and not being able to recreate in the water and losing the tourists that come down to play in the water. So how can we avoid all of this cyclic and reoccurring economic hardship? Well, I mean, it's kind of a simple solution, in my opinion. If any of you have all had fish tanks or played with fish tanks, saltwater or fresh, it doesn't really matter. If you overfeed your fish tank, one day you will come home from work or wake up in the morning and you will find an algae bloom. It will have covered everything in your tank, and you will have to start over again. The reason is because you have become out of balance. Your chemicals have become out of balance, and you likely have too much nitrogen and phosphorus in that chemical makeup, creating that algae bloom within your tank. The same thing's going on in the real world. You know, we're just out of balance on this. And the best way to deal with this is to look to balance. And I believe that that's what the plant has been provided for us for in the first place, is to provide that balance. It provides balance for us within our own bodies. We know that cannabis doesn't cure everything, but it sure seems to help a lot, doesn't it? Well, the reason for that is because it is using the components that it's going to provide to everybody, and then your body is using the components that you need for whatever you're fighting. So that's a neat thing about that, and we apply that to hemp for water and the idea of hemp for water. So what is hemp for water? Well, hemp for water is a mechanism or an idea of how we remove this excess nitrogen and phosphorus. All right, this excess nitrogen and phosphorus is the problem. And hemp loves nitrogen and phosphorus. For any of you that have had the opportunity to grow it, you add a little potassium in there as well and you're good to go. In addition to that, hemp is a nitrogen fixer, a phosphorus fixer, and will sequester heavy metals and toxins. Has been doing so all over the world in what we call bio-remediation or phytoremediation for a number of decades. Chernobyl, Fukushima, Southeast Asia have all used hemp for different cleanup efforts with an amazing amount of success. And I'd like to be able to say that I was the guy that came up with, hey, let's grow plants on the water to clean it up. But I'm not even close. This is a practice that I borrowed from the ancient civilizations. All of them had some sort of rudimentary system for dealing with their waste and their sewage. Most of them did so on a river or a tributary or waterway that was adjacent to their village. And most of them would figure out a way to cordon off or berm off that sewage area, and then they would line it with either littoral plantings on the edges of that area or actual floating mats. The Aztecs, the Byzantines, the Mayans, and a few others all used floating mats. Some of them probably used hemp. And it was one of the reasons is because hemp is an extremely adaptable plant. Now, a lot of you are going, what, hemp hates being in water and hates wet feet. And you're right, it does. And about 70% of the cultivars that we put on the mats don't survive. But 30% of them do, and they adapt very, very well. And what we're doing here is this process, and this is phytoremediation. What you see there is a kind of a mock-up of we use a floating biomat from, it's called Biohaven technology, and Martin Ecosystems manufactures the mats that we purchase and put into place. But basically, they're about 9 to 12 inches deep, and they allow the plants to situate above the water line, which is key. Because if the plants are always saturated in the water line, they will die because they'll be too saturated. Even when you're growing hydroponically, cannabis for medicine, you're going to a wet, dry situation and allowing the plants to dry out at some point, unless you're doing deep water, and then you're really advanced and you're having lots of fun. And this is a combination between deep water and hydroponics using an outdoor system or aquaponics. And basically we allow or create a biosphere between the surface of the water and the top surface of the mat, where the plants will be producing its upper growth. The world between those two levels is where the magic happens, because not only are the plants feeding off of the nutrients in the water, but the biosphere that's created and the microbials and the microbes that are feeding off of the different microorganisms that will start inhabiting the mats also consume nitrogen and phosphorus. In addition to that, we create a fish haven, and it acts kind of as a nursery. So we have a lot of positives out of using this kind of mechanisms. The most positive, in my opinion, is the fact that we're not using any chemicals and we're not using any mechanics or any interrupting mechanics. We are simply floating an island into the ecosystem, growing as much material as we can, and then removing that island from the ecosystem. And that's key, because in the past we've worked with other aquatic vegetation to try and do this similar idea of consuming excess nutrients, and it's a good idea while they're alive, but what happens when the cattails and the water hyacinth die? Well, they decay, and they go back into the system, and they become nitrogen and phosphorus again, and it is a perpetual cycle of the bad instead of removing the bad. So what we're going to do is we're going to grow plants on the water, and then remove them, taking the plants out of the water and the intrusion to the ecosystem with us, and removing a lot of the nitrogen and phosphorus with us. Well, why do we think this is going to work? Well, because it works on land, and it's worked well on land in a number of different places. I mentioned a few historical and recent circumstances, a few more 3 Mile Island, and the remediation for sulfur, and magnesium, again in Southeast Asia. And in addition to that, the Canadians went ahead and did a land study to figure out, the average uptake of an acre, and they discovered that it was pretty substantial. And the fact that it was able to do that on land led us to believe that we can do this on water. We were fortunate enough to run across a gentleman named Dr. Whitehurst, who has over 30 years in the petrochemical industrial world. He worked for a large corporation in the alternative energies and applications sector, and he wrote a white paper for us. He said, "Hey, I'll take a look at your stuff and tell you what we think." And I was expecting, a couple paragraphs here or there, but this is a really impressive paper. It's got over 20 scientific sources, and he outlines from his perspective, from the FIHCE side of things, how fast and what we can do to solve the problem. He believes our idea will work, and he believes it'll work well. And as I said, Biohaven Science is the mats that we're putting it on. What will it do? Well, according to Dr. Whitehurst's opinions and ideas, he believes that if we were able to put a square kilometer, and of course we wouldn't do this all in the same island because that would cause its own problems, but the square area of a square kilometer spread across Lake Okeechobee, we believe that we can pull out 450 metric tons of phosphorus. That's about 960,000 pounds. And we believe that we can pull 7 million pounds of nitrogen, excuse me, not tons. That would be amazing. But 7 million pounds of nitrogen using that square kilometer of Biohaven technology. Now, that's roughly what is going into the lake every year. So that's kind of the amount of nutrients that's being inputted from the stormwater outfall from the basins that enter into the lake each year. What's that? So Lake Okeechobee, as I mentioned before, is approximately 440,000 square acres. It's the 10th largest lake in the United States. It's considered ground zero for all of our hydrological issues in terms of our water flows, particularly from Orlando south. And it absolutely affects everything from Orlando south, including the remaining Everglades and the Keys and the reefs that are in the Keys. As I've mentioned a couple times, we think it's going to be a square kilometer. Imagine what we could do if we put more than a square kilometer on there. What if we put 2 square kilometers on there? Now, what we're working on and something that Dr. Calvin is going to begin talking about is quantifying exactly how much a single plant will uptake. But if Whitehurst is correct, and we can eliminate with a square kilometer of mats what's going into the lake each year, it shouldn't be too long to clean that lake to a sandy bottom and return world-class bass fishing again. Lake Okeechobee used to be, I'm seeing people giggle over there. I'll let you ask a question later. Lake Okeechobee used to be one of the best bass fishing lakes in the world. We had, again, ecotourism that was centered around that activity for most of the first half of the 20th century. In fact, that was our ecotourism in the first half of the 20th century. And it's something that can return again. Now, I'm not a big bass fisher. I'm actually a saltwater guy. But what's important to me is that if we can get to that kind of ecosystem, we've done our job. We've returned it back to where it needs to be, and we're maintaining and keeping our ecosystem where it has to be. So where are we at now? We're solidly into what I call phase 2, which is we've been collecting data for 2 years now. We've proven the concept. We've grown a number of different cultivars on the plants, several plants throughout, or on the mats in several spots throughout the state. And we know that we can grow to maturity and have success with that. Now we need to figure out exactly how much each plant is pulling up, or on an average, how much a plant pulls up. And we need to figure out how to do this at scale. How do we cover a square kilometer of area on the 10th largest lake in the country? That's not an easy task. How do you manage that? How do you make sure that it's not in the way? What's the future look like? Well, in my opinion, I think the future is going to incorporate manless watercrafts. Manless watercrafts or drones, and we're already working on that. We have a volunteer that just graduated Crooms Academy in Seminole County this weekend. He's graduated with an emphasis on robotics and AI, and he has agreed and has already started to do the software development for this entire project. He's committed to doing it, and so is his father to helping him do it. So we've got a majority of the technical lift volunteered for. In addition to that, what is it going to look like? Probably not what you see there. But it will look like some sort of arachnoid or leg kind of vehicle that can float, that can protect the mat, carry the mat to where it needs to be, put it in a specific coordinate, collect all the weather conditions, the water conditions, and do all those measurements on real-time, regular basis. And the GPS locating systems and the AI to navigate and return to where it needs to be. This prevents us from having to go manage several thousand mats all over the place. And we can manage from a central location and send the mats to where they need to go to do their job out of everybody's way and sight, and return home so that we can collect the plants and remove the nitrogen and phosphorus. So what do we do with the plants after that? Well, the plants after that can go to a number of different applications. In my opinion, they can go straight to human application because they're metabolizing the stuff in the water, but that scares a few people, and they're really worried about consuming plants that were used to clean up what they see was a dirty situation. So we have no intention of any of this stuff going to human consumption. All of it is going to industrial use. It'll probably go to composting and fertilizer first. If we get anything large enough, it'll go to animal bedding. If we get anything of volume enough or substantial, we might even be able to start producing nice textile plants off of this situation. Because as somebody that wants to do animal bedding, and the decorticator that some of you saw outside yesterday, I'm looking for stocks that are twice as big as that for my decorticator. But fiber people or textile fiber people are looking for stocks that are that, right? So a lot of our stocks that are going to come off of these mats are going to be thin. They are going to be pretty good sizes for that type of industry, which is, in a lot of people's opinion, way down the road. And if we're growing a kilometer of this, we're going to have quite a bit of them. So, and that's just for one lake, and that's just for the largest lake in the state. We have tens of thousands of lakes in the state, and we have several rivers, and we need to clean them all up, because Lake Okeechobee is not the only problem. I mentioned St. John's earlier. I happen to live around that particular waterway, and it's got just as many algae problems as Lake Okeechobee does. And so does the rest of the country, and so does the rest of the world. So what do we need to do? We need your help. We need you to get involved in your state and in your environment. We need volunteers. We need financial contributions. We need the government to step in and help provide fundings that they're already paying for. The state of Florida has a $25 million set aside to clean up Lake Okeechobee. The governor's doled out some of that money to some projects. They're all chemical or mechanical projects. They're all way lower scale than what I'm talking about. None of them will ever meet the volume or the metric tons of removing nutrients that I'm talking about. And they will all have secondary impacts because they're using mechanics and chemicals. This does none of that. I've been struggling to understand why there hasn't been more response from government. This is a simple, easy solution that is non-intrusive, doesn't hurt anybody, and has all sorts of positives. But I don't know, lots of things don't make sense these days. So I need your help to help get government's attention. I need your help to help fund this idea. If government's not going to get involved, well, then we have to do what I say we always have to do, which is run your government or it's going to run you. So we need to make the initiative. These are some of the people that have already stepped in to help. They are our regular contributors and folks that spread the word for us on a regular basis. I'd like to see this time next year so many logos you couldn't read that. It'd be fantastic. And we welcome any collaboration with anybody that's serious about doing the work. I don't care if you're red, I don't care if you're blue, I don't care if you're yellow, I don't care if you're green. I don't care if you're big sugar, I don't care if you're captains of clean water. I don't care who you are. If you actually want to help fix the problem, let's do it. Because I've been trying for a bit, and I'm getting tired, and I need some help. All right? So these are some of the appendices and sources that you can go to. The HERD poster is a summary of the Canadian study, along with the fertility guidelines that came out of that study. The Whitehurst document is there as well, along with all sorts of resources that you can follow from there. He has an excellent bibliography or works cited on that. This is just a compilation of some of the stuff. And these are some of our contact areas that you can reach us at if you do want to get involved. And with that, I'm going to go ahead and turn it over to the really important part of our project, which is the work that's being done at South Florida State College. And I'm going to introduce Dr. Kate Calvin, who has been instrumental in providing the scientific side of things, because God knows you guys know that I'm only about emotion. I need the PhD to tell you the real facts. So please welcome Dr. Kate Calvin and her presentation of what we've been doing for the last 2 years.
Good morning. We've been at it for a long time. The project has several features, but one of the most important ones for us was we needed to be able to grow plants in grow tents, and that was one of the major hurdles. Other features of our project include figuring out how much nutrients those plants pull from their containers, right, per plant. And then another feature of our project includes certifying clones. So there's several aspects of the project going on simultaneously. We're going to fill you in today on our successes with being able to grow plants in our grow tents, like tall, right? Tall plants in the grow tents. And then the progress that we've been able to make using EPA protocols on environmental analysis instrumentation. So first is my student Nylla Wilder. She's going to come and fill you in on our progress growing the plants. Nylla?
Hello, everyone. Good morning, and thank you for being here. Today, we will be talking about our pilot project on industrial hemp as a phytoremediator of polluted waters. This project is possible through our collaboration with Steve Edmonds of Hemp for Water and Jeff Williams of Central Florida Hemp Growers, LLC. Here's an overview of what we will be covering today. Today we will discuss the problem, pollution in Florida's waters, how this project addresses the problem, rationale for the project, experimental questions in design, results, and challenges for future directions. Freshwater lakes and waterways in Florida have been declining as a result of nutrient pollution. Large amounts of nitrogen and phosphorus in fertilizers, animal feed, and human waste have been identified as the major contributors to this decline, and these nutrients continue to exceed the Florida Department of Environmental Protection's maximum daily load threshold. Cannabis does a very good job of pulling up, metabolizing, and stabilizing heavy metals. Other examples of cannabis pulling up metals in soil are radioactive species and carcinogens. This project is intended to test the effectiveness of industrial hemp as a viable means of pulling up nitrogen and phosphorus from polluted waters. The hypothesis is that the excess nitrogen and phosphorus in the impaired waters will provide the nutrients needed for the plants to survive. And in this image, you can see cadmium, arsenic, lead, and mercury being pulled up from the soil, and those metals are being stored into the leaves of the plants. There's a firm foundation of similar previous studies, including this study by Lafrendo et al. That shows that cannabis pulls up large molecules from water. And in the image on the screen, you can see the molecule on top is the carcinogen molecule, and the one on the bottom is the endocrine disrupting chemical. These are just two examples of the large molecules pulled from water in the Lafrendo project. Plants were grown from seeds provided from Hemp for Water. A semi-hydroponic growth system with minimum soil was used, and the plants were kept in ventilated tents with timed LED lamps and specific media growth. In this image, you can see, in both of them actually, you can see the grow tents, and in the one on the right, you can see the ventilation and the LED lamps over the plant. Our specific growth strategy includes two major components, the FIHCE system and the Kratky method. In the Kratky method, the plants sit in net cups inserted into a large lid, and there's a gap of air between the surface of the water and the bottom of the lid, which aerates the roots. This provides oxygen to the root system and removes the need for an air stone. The roots continue to grow in the solution as the level reduces. The FIHCE system features a growth container filled with a medium and a separate reservoir that houses the nutrient solution. Some growers choose to fill this container with soil, whereas others opt for soilless media such as cocoa coir. These media feature gaps that allow oxygen to enter and aerate the roots. This removes the need for an air pump. Wicks are used to passively transport nutrients solution to the roots. One end sits in the nutrient solution and the other in the grow container. Wicks pull water from the reservoir liquid to the roots using capillary action. That one. Here's some examples of how our plants are doing. In the first image, you can see the roots emerging where the strings are, and you can also see them growing along and inside of the strings. They're taking advantage of the wick system. You can also see the clay balls inside of the outer basket. In the second image, you can see the same clay balls surrounding a much smaller basket, which holds the plants. This enables the usage of minimum soil and encourages the roots to grow toward the water. In the third image, you can see the container which holds the plants and our growth media we use to feed the plants. There's approximately a 1-inch gap between the reservoir liquid and the pot. And in the last image, you can see a healthy plant which has a pretty good root system, most of which is constantly underwater. We have developed a method of growing these plants that condition them to seek water directly. They have demonstrated the ability to survive on these grow mats for 3 months. Our ultimate goal is to have several plants placed on a grow mat like this one. Ideally, a large number of mats, each with several plants that live for a long time and have a positive impact in removing pollutants from impaired waters.
Thank you very much.
Didn't she do a wonderful job? Yeah. She did. So, we've come a long way. We've described to you our most recent iteration of growth attempts. Like I said, we've been at this for 2 years, and we've just now gotten to where we can reliably, without worrying about it, have really tall, robust plants. And so the next thing we're going to start doing is working really heavily toward the goal of measuring the uptake now. That's where we are. So one of the things that is curious about when we put the plants out on the mat is the daylight changes, right? You have all these outdoor stressors on the plant. The plant goes from being tall and fluffy, like these are freshly put out on the mat. The plants go from being tall and fluffy to yellowing leaves, and in many cases they stop growing. And the only leaves that remain are the topmost leaves. That's also natural to the plant life cycle. With the sunlight changing, they're going to finish their life cycle and they're going to start to flower. So how are we going to measure what's going on there, right? So in order to address that, and I'll be talking about this a little bit later, we're also, in addition to just measuring biomass for an indicator of uptake as well as the environmental analysis, we're going to be looking at what are the plants making with the nitrogen that they're taking up, or the phosphorus. How are they metabolizing it if they're not growing? And so I'll be talking about that in the future as well. This is pictures of the plants and what they look like after they've been out for a while. They have stalks, and then the top leaves. And so this plant is getting ready to start producing seed. And you're going to see the offspring of that plant here shortly. This is one of the very tall plants from the previous slide. It's a single stalk with all of its top leaves. Okay? And so what we want to do is look at these and figure out what they're making with the nitrogen, since they don't have a lot of leaves left. So metabolic analysis for that is where we're headed. Here's one exception. This plant actually went, I'm on the grow mat. I'm the Hulk. You know, it actually grew a lot, especially during these days. I like to, when I'm describing this particular plant to people, I'm only able to grow a few plants at a time, so I look at each one as an individual. Isn't that kind of silly? But I know each plant. And so when I'm describing, what this plant was doing, I describe it as going through puberty. You know how when you boys are going through puberty, one summer you shoot up a foot and a half and you beef out over one summer, right? That's what happened here. This is a male plant and it has pollen pods here. And I texted Steve, I was like, look at this plant. It's grown so much over the course of a week, to 10 days, whatever. And it even survived the alligator. But
That's the guard gator.
yeah, she's always around, and her babies are too. It's cute. But I ended up collecting this plant back to the mat when it started to, I could tell that it had finished its apex moment of pollen production, so I brought it back in, and I'm putting it back into vegetative growth, and I kept the pollen pods because this is going to be an amazing plant. So, but this is one exception. Most of the plants do not grow and make more leaves. So now that we're ready to start looking at how much are these plants pulling out, we need to know the baselines first. How much nitrogen is in the pond? How much phosphorus is in the pond? I'm basically trying to starve the plants, right? With most hydroponic grow systems, they want to produce these big, lush plants because they're going to harvest, right? They want good buds and, as big a plant as they can possibly get. I want tough plants. So I'm starving my plants. I'm feeding them just a little bit more than they would get on the mat, and I'm going to start to decrease that as well. So what are these baselines? And then what are the quantity of nutrients that can be consumed by a single plant? So the method that we're using to test this is the common instrument used in environmental labs, because if people are going to believe what we're trying to say, we have to use the same science that's used in the industry. And our college backs this project 100%. They purchased this instrument for us to use, and it is not inexpensive. It's very expensive. So we're going to really, really make it be our workhorse for this. And the standards are rigorous for passing muster, shall we say. When you calibrate the instrument to look for quantitation within a very tight range, your calibration curve has to be almost perfect in order to pass muster. It has to be 0.999 something. That's almost 1. That's almost a perfect line. And so whatever data we're able to produce has to meet this standard. Nylla made this standard, by the way. So, but this happens to be a very nice piece of data. Not all of our runs are perfect. You're going to see a run where we had some experimental error, but that's where doing it repetitively comes into play. That's why they call it research, right? We have to do it over and over and over again. So what happens when we're doing this is you've got one line here. So over here, not in the photo, are the samples. The samples are drawn, and they're split into two paths. This path is the nitrogen chemistry, and then this path is the phosphorus chemistry. So from a single sample, it's split and analyzed simultaneously, one for nitrogen and one for phosphorus. And so we have two sets of standards, two sets of calibrations, two sets of results simultaneously. It's taken us a long time to get to this point because this is not my background. And so it was a learning curve for me to learn how to do this. And so what this photo shows is, I don't know if you can see the bubbles. There's little bubbles here. It's called segmented flow analysis, and each segment between the bubbles is a section of the chemical reaction happening. And so as this flows through the detector, each section or each segment of the chemical reaction is being read by the detector, and that's what enables the signal to go up and then down again. Okay, so that's basically how this works. So here are some data that we have. What are the baselines? Well, this is our preliminary data. We're gonna start launching into doing this over and over and regular. So for the pond water, our nitrate nitrite is, our nitrate nitrite is 0.2, so it's 217 parts per billion, basically. So this instrument enables us to measure sub-part per million. So it's very, very sensitive. Our total Keldol nitrogen, which is a measure of the organic nitrogen as opposed to inorganic nitrogen, is 1.853 parts per million, and that puts us in the uh-oh range up here. So here's nitrogen, and here's this is taken from the Florida Administrative Code. And so this is a threshold, annual geometric mean total nitrogen. And so we're on the high end here, and then our phosphorus is also very high. Okay, and so I don't know if you recall, but when Nylla was giving her slides, there was a picture of our pond, and there was frothy bubbles along the side of the pond. I tend to think that's phosphorus related. I might be wrong about that. I don't know, but our pond on our campus is very high phosphorus content. And now, for the plant food media, what I'm feeding the plants, TKN nitrogen tests at almost 8, sometimes 7, so it's in that range. We're gonna do it over and over and get an average, and then the phosphorus is around 4, 3.74. So how much is being taken up now? So what we have is, just like any scientist would do, I don't know, let's try this, let's see what happens, right? Let's just try it and see what happens. So this was our first test, This was our first test here. And so what you'll see is we have less detected in the sample that had this is a very small plant, this is considered our control. There's plants in there, but no root to water contact yet in the reservoir. And it has taken up less than the test group, which are these very tall and fluffy plants here. And so, but that was after 2 days, no controls on there. I just wanted to see, what does it look like if I just try this and see what the measurements look like. So then we did a brand new food mix, and then we ran the test again 1 day after feeding. So this is that experimental error I was telling you about. This is where the results from our analysis showed that the phosphorus actually got more concentrated in the food medium, which I don't believe, because that didn't happen here. But something wasn't quite right with that. So for our completed calculations, we used just the nitrogen, and we were able to use this series of calculations to get to the point where we get 13 micrograms consumed by one plant and 8.8 micrograms consumed by another plant. So in here you'll see, how do I know the mass of the plant? I weighed everything. I weighed the baskets, the stones, the dirt. I weighed everything, and then I took the difference to get the mass of the plant. But plants are 90% water, so then I had to subtract 90% from that to get the mass of the plant. Again, this is an estimation, but I came up with the plant minus the water mass here, and that would be 5 grams is the mass of the plant in this study. So we have the mass in grams, the total mass of these two added together, the percent of each of the total mass, the total nitrogen consumed, which is the same for both, and then converting it. So one thing I haven't told you guys is that parts per million directly translates into milligrams per kilogram. And so that's that. It's parts per million here, milligrams per kilogram, and then we convert that to milligrams per gram because I want to deal with the plants in masses of gram. We could leave it kilogram, but I chose to change it. And then the milligrams per gram consumption of the plants based on percent mass. And so that gets us to these. And this is for 1 day, and this is for one experiment. I've been since gathering every 4 days I have 4 sets of 4 days of data that I'm ready to analyze now. So our current trials, when I say 4 days, 4 sets of data, each set contains an evaporation-only control, meaning I've got the outer basket, the clay balls, the inner basket with strings only, there's no dirt in there. Because I need to know how much of the nutrients just the strings are pulling up, okay? So there's that one. And then I have another control, outer basket, stones, inner basket with strings and dirt in there because I need to know how much of the nutrients are being held in the dirt, right? And then here now I have the outer basket, the stones, the inner basket, the dirt, and the strings are still in here. And then I have a small plant. And I was gathering data. I planted a seed because I don't know if there's a chemical change in the soil when you've got seeds or not. I don't know if the uptake is starting to change just because you have a seed in the soil. I don't know. I'm assuming that it could happen. So I was taking data on this from just the seed planting all the way through sprouts. I can't use this as a control anymore because the roots are touching the water now. I have to have a new control. But I do have enough data to analyze up to that point. And then here are our large plants. This is almost getting too tall for the grow tent now. But these are all of our plants, all the controls. Believe it or not, this one came out to be about the same mass as this one, but that's because they have the same number of nodes, right? Most of the mass of the plant is in the leaves. And I was like, no way, they can't be that close in mass. And sure enough, I counted the number of nodes, and this plant is short. This plant is more Trump-like, and this plant is more CBG-like. And these 2 plants came from the same seed batch from one plant. These are 2 seeds from one plant. So another interesting thing that we're going to see coming up here shortly is the difference in resilience and the difference in proneness to nutrient issues. So the challenges that we face, I told you in the beginning how multifaceted this project is, right? So I'm constantly learning, I'm constantly being force-fed nutrient deficiencies, right? I get to learn everything I ever didn't want to know about sick plants and bugs and things like that. My biggest 2 problems in the grow tent are root aphids and spider mites. But I've come up with a way to drown out the root aphids fairly reliably, and then my plants come back nicely. And then with the spider mites, I use the same product. It's insecticidal soap. I put it in like a deep a graduated cylinder, a big one, right? I've got 2-liter graduated cylinders. I spray it, I put it, and then I take the plant and I dunk the whole plant in there to get rid of the spider mites, and that helps a lot. That gets rid of it faster than individual spray. I also drown the root aphids by dunking in the same insecticidal soap. But here, for example, same plants, these are the same plants. This one's gotten taller, and this one's developing what looks to me like potassium deficiency, so I've had to change the food here to help. And it's okay with me. I'm not that worried if the plants are tested, right, by these deficiencies, because they're going to have the deficiencies out on the mat, right? I just want to see what I can do to optimize my conditions. So we have that. We have different phenotypes and traits within the same seed batch. I've talked about that with you all. Different strains of plants. So this is going to go into clones. I say the word strain, but I think cultivar is a better word. Is cultivar a better word? But Personal choice. So my favorite plants to work with are CBG because those are the tall, fluffy ones. But Trump are short and fluffy, and they're tough, boy. And then tenacious. I was saying, give me some tenacious seeds. Give me some tenacious seeds, right? So he brought me some tenacious clones, and then I also now have Trump tenacious cross seeds. And so, boy, those are fluffy. Those are doing quite well. And those, remember the pollen going through puberty plant on the mat with the alligator? That's a Trump tenacious cross. So I definitely want to keep that pollen. So clones, this is part of our project, and I have 2 sets of clones going. The first one came to me, it's the tenacious clones, right around spring break, so right around March 11th. They're doing just fine. Amazingly enough, I heard talk about root rot before, right? I don't have issues with root rot. How is that possible? Well, I use the great white mycorrhizae. I use that, and that keeps my roots, fat, white, and happy, I don't have a lot of green problems. I'm amazed at that. And I don't have a big issue with root rot. Root rot typically looks brown, right? Is it brown and slimy?
Slimy brown.
Yeah, I don't have that. I've got algae, but they're going to get algae on the grow mat. I try to rinse the algae off because it doesn't really hurt the plant, but it does slow the uptake of the nutrients. So I try to rinse it off, but I don't want to go like that to the roots too much either, because that disrupts the root hairs, right? But back to my clones, they're doing a fine job. They're on their way to being certifiable because they're 12 weeks along. So I'm very pleased about that. And then my Trump clones are also, you should see their roots exploding. Very nice, very nice. And one of the best things, I'll close with this. Let's see, So future directions, we're going to continue doing our quantitative work because we're just getting started on the discovering how much one plant can take up in a life cycle. I talked about this. For plants that don't grow on the mat, we're going to figure out what they're doing with that nitrogen if they're not making leaves and growing taller. Determine which strains are toughest and best suited for the grow mat, and then continue refining the growth medium. And then clone certification will also be continuing. To acknowledge, we would wish to thank Steve Edmonds and Jeff Williams for making this project possible. We wouldn't be able to do it without you. We also thank South Florida State College administration for its committed support of this work. And we thank the previous participants who've pushed this project forward. If it wasn't for Kendall Carson, I wouldn't be standing here. We would have no project. And she's not with the college anymore. But because of her participation in a previous hemp conference, here we are today. And then the previous students who have worked on the project, whose names are on the slide there. One thing I did want to say in closing is I appreciate your appreciation of the plant, right? I was scouring the internet every day looking for information. How do I find out about this? What's going on? Why does my leaves look like that? And what's going on with this plant? And how do I do this? And where did I find it? Resources like Grow Weed Easy. Cannabis enthusiasts are so enthusiastic, and they're just devoted to growing the plant. I love growing these plants. Like I said, I'm only able to grow a few at a time, and I don't name them, but I might as well, because I know each one by what its roots are like, and they have so much personality, if you can say that, Anyway, that's it.
Awesome. Thank you so much, Kate. Now you guys know why I have PhDs on my team. That's the data side of stuff, and without that, we won't be able to get anywhere. So I thank Dr. Calvin and South Florida College and Jeff Williams, because without their help, I wouldn't be here either. So much appreciation there. We're going to move forward with our last presentation, and this is probably one of the most important informational things for folks in Florida trying to grow, because one thing that we do have challenges in Florida for sure is with pests. We've got prolific pests and some that other places don't have. So with that, I'm going to introduce Dr. Lance Osborne, and he's going to give us an education about pests. Thanks, sir.
Thank you, appreciate it. Okay, I'm going to give a talk that would normally run about 3 hours, so I'm going to have to jet through this. Okay, I'm going to talk about managing insects and mites using banker plant systems. Now, this has been a team effort. This is DPI, University of Florida, USDA, I list a few of my colleagues that have been instrumental in helping me develop some of the data that I'm going to talk about. This is just a snapshot of what we're doing mainly in greenhouses, okay? We work in protected ag, so the cup system that was mentioned earlier, we work with just, greenhouse production of ornamentals. This is data and ideas that have been generated over the last 10 years working in greenhouses, mainly with ornamental plants. Okay, biological control is really just a tool. It's one of the tools in your arsenal to be able to manage pests. We have a number of different compounds that are mainly based on oils and soaps and those sorts of things that we can use to help us manage pests. But we feel that biological control is going to be a major player because of some of the issues with treating plant material that it's sensitive to having residues on them to the consumer. Okay, it works well, but growers in Florida have a number of problems with adoption, and I'll go through a few of these. Economics. Okay, most of the biological control agents that you might want to use in a commercial greenhouse generally come from some other place in the world, okay? We get predatory mites and other things that come in from Israel, from Mexico, from the Netherlands, Belgium, and those places. So you're paying a lot of money just to get them to you, okay? So you may spend $5 for 1,000 mites, but you have to spend at least $25 or so just for the shipping and packaging and everything else. So that's one of the problems. Second is when you bring them in, and I'll talk about it a little bit more, is that they, after I get off a plane coming back from Europe, I'm not worth the damn, okay? And these things have major issues and can be impacted by the shipping. Availabilities. Okay, I'm mainly talking about the fact that a grower may find a hot spot and he would like to do something immediately to solve the problem. It can take up to a week to get some of these natural enemies, to order it and get it into the pipeline, get it through customs and everything else before you can ever put them on the plant, if you're lucky, okay? So there's a problem with getting what you need in a timely fashion. It gets very expensive if you just have standing orders coming in on a regular basis. You may not need all that firepower, so to speak. Pesticide interactions. We don't operate in a vacuum, okay? We may have spider mites, mealybugs, you may have some plant diseases, you may apply something to the plant that could disrupt the biological control. And when we're talking about ornamentals, we have a lot more tools at our disposal, and many of those can cause problems with biological control agents. Many of the materials that are being used in the hemp industry are, OMRI rated or materials that don't have to go through a registration process, and they're a little bit more, a little softer on the natural enemies, so we don't have quite the interaction. Some of the residues and some of the pesticides can last up to 6 months, so these don't, okay? Quality control, like I mentioned, the insectary that makes the natural or produces the natural enemies may send out a real good quality product, but they have no control over what happens to those bugs the minute they leave the insectary to when they arrive at your place. We had the people with the big brown trucks that would park in the parking lot in the park next door, and they'd eat their lunch. One of the guys was sunbathing over there for an hour. Okay, well, those trucks aren't air conditioned. Those insects in the truck a lot of times would show up dead, okay? Now, some companies will put a Hershey Kiss in the box, and if it's melted, then they know that they were exposed to high temperatures, okay? But we do have problems with quality control. Too many pests, not enough tools. Unfortunately, Florida is ground zero for invasive species, okay? So we constantly have new things coming in. We've had to deal with our first plants that came, hemp plants that came to Apopka, which is just a few miles from here. There was 2 exotic pests, hemp russet mite and the cannabis aphid. Both of them came in on cuttings, okay? So we don't always have tools for some of the pests that show up because obviously if they're from another country, we may not have ever even seen them. So we have no idea how to manage them, okay? So we make our best guess and try to eradicate them or manage them if we can. So a solution is a modified banker plant system, okay, or an open rearing system. These have utility if you feel like purchasing doesn't work for you or nobody sells a particular biological control agent that you would like to use. Okay, the idea is, say, let's pretend, let's see, there should be a, okay, this is, let's say this is a hemp plant, and let's say these little red squares are spider mites. Okay, so your plants are infested with spider mites. You can buy in natural enemies and release them onto the plant. If they come in good, they will start feeding on the spider mites. This is, in the case of spider mites, this would be a corn banker plant. And it has a host-specific mite that feeds on corn. Okay? The predators and natural enemies that we want to use for spider mites in hemp will feed on this mite. We can put the two together, and the spider mites that feed on corn and the spider mites that are feeding on your hemp, they don't cross over. Okay, so we can put 1 million of these mites into the system. They may try to feed, but they're not going to establish a population. Okay, so we can use this in ornamentals without causing any aesthetic quality damage to the plants by having these host-specific pests. And we test every system before we allow a grower to use it, just to make sure that that particular host on or banker pest, or let's call it alternate host, doesn't feed on their crop. You can release natural enemies by just putting this plant in here, and they go back and forth between these two plants. So the idea is to have your crop, to establish or have these banker plants into the greenhouse before you even put your crop in. And so if a pest happens to show up, there's already an arsenal of natural enemies there to feed on it. And they can act like scouts. They're running around. If they don't find something in the crop, they're going to starve to death, okay? Does everybody understand that concept? Okay, thank you. Okay, so a banker plant will use an alternate host. So we're using papaya for whiteflies, we're using corn for spider mites, we use peppers for a predatory thrips that feeds on other thrips. And so we have systems that use alternate hosts. In some cases, we use confined hosts. So you'll see some packages that have their little, they call them sachets, or little bags that you can hang on your plant that have a bran in them that has a mite that's just feeding on the bran, and then the predators inside there feeding on the mites that are feeding on the bran, okay? And so they're kind of like time release, and you can hang them on your crop. So that's a kind of a version of a banker plant system. There's potential to sell the entire system. We've had one grower that's producing the banker plants for whiteflies and selling them to a number of his colleagues, okay? This is an area, in my estimation, that's wide open for somebody that's an entrepreneur. You can sell the entire system, and there's a number of other things. Problem is you can't sell it outside the state because these are pests. You can't send them across the state line. But that gives our growers an advantage, okay? These things may not work in other states, and you may, again, it's something that needs to be investigated, but it may be specific to a region. Some of these things may not work in more northern climates. We catch stuff that works in Florida and develop systems to rear them. Okay, it's used to establish natural enemies, so you get them into the system early, which is absolutely critical for a biological control program. Used to increase natural enemies numbers. You can still buy some. You don't have to buy nearly the quantity. You put them on the banker plant, and you get this a biomagnification. So for every one that you release, you may have 10 or 20 within a week or two. Okay, so you increase, and so you get more bang for your buck. used to evaluate quality of natural enemies. We found that some that were coming in, that when we put them on the banker plant, they didn't do anything. They'd run around, they looked healthy, but they didn't lay any eggs. Okay, so we found that there was issues in the product that was being sold by many of the insectaries with some of the predatory mites. But it gives you a positive feedback that what you have is actually working. Okay, it can be integrated if pesticides are necessary. So a lot of times we'll either have these individual plants scattered throughout the greenhouse, and if you have to spray, plants could be moved, or you can put a plastic bag over them. We're leaning now toward more of a banker islands, where you have a whole group of plants that you can just cover and not spray, and then just remove the cover when the residues are gone. And we know from our work at the Apopka Research Center that it's safe to use on hemp. And you can grow your own. It allows you to actually grow your own natural enemies, so if you need something, you can just go clip off a leaf of one of these infested banker plants and put it in an area that needs to be treated. So as mentioned, we have banker plant system for thrips, whiteflies, spider mites, aphids, and now we're working on one for mealybugs. Okay, mites has probably been the most successful and been used commercially in a number of greenhouses in Florida. They've been successful, mainly talking about two-spotted spider mite, Tetranica certici, but we're also having problems with another mite called Glover mite. And this is a major pest to hemp, okay? You get ones that are brick red like this, and they're a little more difficult to control in some ways than two-spotted spider mite. Typical damage, they feed on the cells and causes stippling. Broad mite is another major issue that the banker plant works well on. These are about half the size of a two-spotted spider mite, so they're hard to see. I go everywhere with hand lenses. I use this to read my pill bottles, but we won't go there. Okay, so they're very tiny. We have one of the largest growers in the state of Florida. He had the premium quality plants. He had major problems with spider mites in his stock plants and throughout, growing ivy and croton and a lot of ornamentals. So he basically set up just a small 3 different rooms, and he'd alternate with growing corn in here. So they're all in different stages. They'd harvest the corn. So they'd grow the corn under these artificial lights. When they get to about this stage, they would move them to the next phase and infest them with these mites that we gave them. And they're called Banks grass mites. And so they would feed on the corn. This is Banks grass mite. You can tell, it's very easy to tell from a two-spotted spider mite. He would buy natural enemies in and just seed the plants. He'd put them in his greenhouses, and then he'd hang them throughout the green nursery, okay? These plants, prior to using this system, they would treat once a week with products that you can't even use, or you can't even entertain the fact that you're going to be able to use them. Okay, most of these pests that we're talking about that attack hemp, in many cases, are already resistant to many of the compounds available. So, you may wish to have certain chemicals, but in many cases, they're not working even in the ornamental industry where they're allowed to be used. Okay, so they hang these up in the crop. He started doing this, and he went from once a week to once in a year that he had to use use a chemical. In that case, it was a soap. For mites, we have multiple different systems that grow all sorts of natural enemies. There's a fly and a number of predatory mites, and then Stethurus, which is a small beetle. This is Persimilus, again, commercially available. This is the one we had problems with quality that they didn't do their job. They looked healthy, but they just didn't do what they were supposed to. This is Californicus. We prefer using this, especially at densities where the mites are fairly low, because they can make a living on just having 1 or 2 eggs a day and survive. They also feed very well on broad mites. Persimilus will starve to death before it will eat a broad mite. So we like using Californicus, or a combination of Persimilus and Californicus if you're going to use predatory mites. Amblyseus swirsky, it does feed on broad mites. It does feed on thrips, and it feeds on hemp russet mite. Okay, now we were getting ready to start a program and evaluating its impact on broad mites. Then we had an invasion of hemp russet mite. I'm not allowed to work on hemp russet mite except in a small little room, so we had to destroy all those plants, and basically I don't have any hemp plants anymore. I'm letting the greenhouse go fallow, and then we will start up again once I'm sure the hemp russet mite is dead. But we have limited ability to work on that. But we do have some data. Before we trashed them, we tried a bunch of chemicals to get rid of the russet mite, and those didn't work very well. We put sachets of I'm going to say a Swirsky on the plants, and actually they did a good job. Okay, we have another predator that has a wide range of pests it'll feed on called Franklinothrix. It feeds on spider mites. It's a native of the U.S. It's found in low-lying vegetation. It's a very, very large and very aggressive thrips predator. It feeds on whiteflies, mites, and thrips, and you can rear it. It's easy to grow. This is the first instar feeding on a thrips. Let's see. Can you get that to... That's not going to work, I guess. Okay, this is the adult, and it's eating a thrips. So you can see they're huge compared to a regular thrips. These feed on echinothrips, which has become a major problem for many of our growers, and we had some issues with this in our greenhouse and our hemp. We released a few, and it was dramatic. Within a week, we started having a major reduction in thrips populations. And these things, we've been working on them for many years, but we just didn't have a way to commercially produce them. Now we have a way that we can grow them. We can grow them ourselves. We have an artificial diet to feed them. Okay, now it's doing it on its own. This is just a quick and dirty experiment that I had my biologist conduct. We had 4 cages, 1 bean plant per each cage. We inoculated them with spider mites. You can see that this is the total number on 4 plants, so the sum of all the mites on the bean plants in the 4 cages that had nothing added, or this had the Franklinothrix. This is the cage that had nothing added to them. So in 2 weeks, it went from like 600 to over 8,000. We quit counting the plant after 1,500 mites, okay? But it only lasted till week 2 because the control plants basically died. You can see they went from 645 to 17. Now this should have a 157 or something on that because the female or the adult mite or thrips died, predator, but it did lay eggs. There was 12 immatures just on that plant, so the population was going to be eradicated shortly. So it's just a testament of how quickly they can knock a population down and how voracious they are. So 8,000 versus about 150 total. Okay, hemp russet mite, again, that's a work in progress, and we will basically skip over that. Possibly works on hemp russet mite, but I don't want to say it does for sure until we have time at some later date. Maybe in a commercial greenhouse we'll get the opportunity to work on it, but as far as the University of Florida, we're not allowed to work on it at this point in time. I'm going to talk about whiteflies. We've had a number of phone calls from producers of both cannabis and hemp, industrial hemp, that have had major problems with whiteflies. This is one that will cause people problems throughout the state because they fly in from other crops. They are a virus vector. Luckily, we haven't seen any viruses transmitted by them yet, but this is a pest that's known to be extremely resistant to pesticides, okay? And biological control is the way most people are going for managing this. Unfortunately, the tools that we have for it commercially right now, as far as biological control agents, are not very good. There are 2 species of beetles we have, about 3 or 4 parasites, and 3 different fungi, okay? The backup plant system is a papaya. The alternate host is a papaya whitefly. We have a Incarsia sophia, which is different than one that's being sold. We have one beetle that's sold worldwide that came from a papaya in our lab, and then we have this PFR, which is or Ancora, or lots of different names, but this was also found in a papaya. We patented it, and the University of Florida licensed its rights to Certus. This is what happens to papaya. These are all whiteflies, okay? They don't get on the crop. Incarsia sophia, the little wasp, when it lays an egg in a whitefly, the whitefly turns dark. This is a healthy whitefly. This is one that's been killed. This is the adult, a little golden wasp. The banker plant system, generally we put it at the end of the bench so that sooty mold and the honeydew and stuff doesn't impact your crop. And the natural enemies all fly. Okay, this is just a stockhouse looking at whiteflies. The green bar is using biological control. The red bar was using pesticides that were applied at 3, 5, and 6 days, 6 weeks, in order to bring this population down. At the end, they had fewer whiteflies. If we would have treated with the chemical here, we would have had no whiteflies on the biological control program. Now, this is using old tools. This is using Delphastus and this particular wasp. We have newer and more effective predators. This is Delphastus pallidus, okay? And it's a voracious predator of whiteflies. It doesn't matter what kind of whitefly, it seems to eat any whitefly it can find. It's about half the size of the one that's sold commercially, Delphastus catalini, which again was found in a papaya and commercialized and now sold all over the world. This one is the updated model, and it is it's a cool little beetle. These are the immature stages, feeding on larger instars. They'll feed on anything they can catch. They'll feed on the eggs, the instars, and adults. This is the bottom of a papaya leaf, and I don't know if you can see it, it's kind of dark, but these are all pupae, all beetles. Just by releasing a couple beetles on a banker plant, this is what you end up getting. They fly up and they look for food in the greenhouse. And like I said, to make a living, they need a lot of whiteflies. And so they basically will drive the population almost to zero with just one banker plant in a normal size research greenhouse. Amblyseus swirsky does feed on eggs. This is a sachet. And they come out, the predators come out of a little hole. This can last for 3 to 4 weeks, unless you have four-legged pests. And this is what happened, okay? We had a mouse or a rat, and it went in through and ate every one of our sachets. They left the hemp alone, which surprised me. But again, there are some issues. One way we got around it is using a banker plant. This is a pepper. We used in poinsettia crops. We release Swirsky on there. They will feed on the pollen that's on the pepper, and they'll hide in these little domatia that are on the side of the leaves, and they build up a very large population. The grower just moved these plants around, and it worked extremely well for managing whiteflies in their crop in conjunction with the papaya. Okay, thrips. This is chili thrips, which we have a major problem with in Florida, and it does get on, it's a major problem on citrus in the cup situation, and it also feeds on hemp. This is echinothrips. Okay, they pupate on the leaf, and then the adult is black with a kind of a light stripe across it. They caused a lot of damage. And this was a greenhouse that was loaded with hemp, but the echinothrips were taking the plants out. There are no viable controls that you can buy for managing echinothrips on ornamentals and or hemp, except for Franklinithrips. And we cleaned up that whole greenhouse within a month after releasing the natural enemies.
That's it? All right. Awesome.
Okay, thanks.
Well, thank you, Dr. Osborne. That was a great one. Thank you. A great education. I certainly learned a few things that I didn't know before, so thank you very much. We do have a few minutes for questions and answers. Are there any questions? Okay. Mike Wave coming in the back there.
All right, hang on, Betty, hang on. Don't make me run, it's too early for that.
Okay, this one.
Hi, Kat. I wanted to ask, what is the length of your daylight during summer solstice in your area?
How much daylight?
Now, how much daylight do you get at summer solstice?
About 14 hours.
14? Okay, I would have thought you would got more.
Yeah, unfortunately not. We planted outdoors early last year, at the end of April, beginning of May, and found that it did stress the plants out. So our growing vegetative season in that area is from, I would say, mid-May until the 1st of August.
I'm gonna follow up with that. I think that that the light cycle is going to be our biggest challenge in Florida. The longest stretch that we get is 14 hours. So if we're going to do things at scale, we're going to have to figure out how to trick the plant to stay in veg and not go to flower. That is going to be one of our largest challenges in Florida for mass production. You had another question back there?
How you doing? My question is for Dr. Calvin. In testing your hemp plants, it's a two-part question. One part is water pH a factor in your testing? And also, are you testing these plants at different stages of the plant? For example, like if it's in veg versus when it's flowering for the nutrient uptake?
So pH, I try to keep it 6 to 6.5, and I measure it all the time. So that's pretty consistent. And let me tell you what, it took a while to get there. At first it was, 6, and then the next day 7.5, these crazy fluctuations. So I was able to get it to be regular, 6, 6, 6.5, 6.5, 6, so I'm happy with that. And then I want all of the grow tent plants to stay in veg. They're at 19 hours of light. That's their cycle. I have not tested how it would be. I have not mimicked outdoors inside the grow tent, but that's a future plan. Yeah, because I want to be able to predict what's this strain of plant or cultivar going to do once we put it out there. And so that means I'm going to have to withdraw some of the food that I put in the medium in the tanks and mimic the light conditions better. So, does that answer your question? Yeah, so different life cycles, not yet. Yeah.
And back to the light for a second. One of the things that I found is an economic solution. You only need 6,000 lumens to trick the plant. A fairly cheap solar light will do the trick. String lights work well in houses. You just need enough to trick it a little bit. Any other questions?
Hang on, Mark. Yeah, so I can record this.
What I was also saying about that was, as you know, during different cycles of the plant, there will be uptaking different nutrients for the different production.
Right, and I had some plants go through this big giant growth spurt where they drew up so much volume of the liquid water from the container, and then it slowed down. And those are some of the ones that I haven't analyzed yet, so I'm really curious to see what that's going to say.
And then Gene.
Greetings, my name is Patrick Burks. I'm a third-year agriculture science major with a concentration in entomology. And my question, I have a few questions. One is, have you ever come across an insect that didn't have a natural enemy and was resistant to the pesticide? Also, has you released a natural enemy that has turned against you and actually killed your crops? And another question I had. Oh, my bad.
That'll be for Dr. Osborne.
Okay, you asked about, did I have anything that turned rogue on me and caused problems with the plants? No, but I spray more pesticides in my research program to kill natural enemies because I can't run experiments on the pests because I have the things eating everything. Have I found anything that doesn't have a good natural enemy? Of course. I mean, there's grasshoppers, and there's a lot of things, but these are the major pests that we deal with that we have to build an IPM program for them specifically because you can count on getting mites, you can count on getting whiteflies. Does that answer your question?
And my other question was, I know I did a research project trying to kill actually cockroaches, and I know that the raid and things that we sell at CVS doesn't necessarily work. I know that insects, they morph in every 2-3 years, and you have to come up with a new product. Have you been having problems with that as far as updating the new pesticides that you have to have every couple of years?
For spider mites with new pesticides every couple of years, by the time we even get the product registered in the United States, if it's been used or found in, say, Japan or something, before we even get to use it, there's already a refereed manuscript on the resistance of spider mites to that particular compound. So it's a battle that we fight constantly, and the only way that we can mitigate that is to try to develop tools so we don't have to rely and do this weekly application of pesticides against these pests.
Greetings, my name is Javon Bell. I attend Florida A&M University. I'm a sophomore and I'm currently studying agribusiness. And one of the questions I have for you guys is when you see spider mites on a hemp plant, because if I could recall earlier, you said that when you can use the modified bank solution before the insects actually invade the plant. So I wanted to ask, when you see spider mites on the plant and then you use the modified bank solution, will it reverse the damage that's already been done to the plant?
So how much damage has already been done?
So would it reverse like the damage that's already been done to the plant from the spider mites?
No, you're not gonna reverse the damage that the mites, because they've gone in there and killed the cells feeding on the contents. So that's history. All you do is prevent additional
Degradation.
damage to the other cells, and basically the plant will overcome the nutrients lost by those particular cells. Does that make sense? Yeah. Yes. I mean, it depends on how bad it is. I mean, spider mites can cause complete defoliation. But we deal on developing programs that you don't even see the damage because we're dealing with ornamentals that the aesthetic value, you can't sell the plant if it has too much damage, or you can even find the spider mites. So we're dealing at a level that's not causing significant, disruption in the production of leaves and roots and all the other stuff. Does that make sense? Sure.
Hi, Dr. Osborne. My name is Ashley. I'm a grower in Fort Pierce, and I want to know where we can get more information on the banker plants and all the information that you presented to us.
You go to my website, or I think you're going to be giving out our contact information, or you can come up and I'll give you my contact information. If there's interest in the state of Florida, we can have a training program at Apopka where we have all the pests and the banker plant systems to show. I mean, we've done it for ornamental growers. We'd be more than willing, if somebody's willing to organize it a little bit with me.
I'll help you with that.
Okay, we'd be more than happy to do it. And we can get you the plants and everything, and so you can start it yourself.
Excellent.
Hi, good morning. My question is for Dr. Osborne. How close do the banker plants have to be to the main crop that you're trying to protect?
Could you repeat? I can't.
How close do the banker plants have to be to the main crop?
We're moving from being fairly close with predatory mites. They can balloon a little bit to these pests or predators that fly. So we can put them over in a corner of the, now, ideal in greenhouses. Okay, so we can put them and they'll fly throughout most of the greenhouse. In the field, I'm not sure how far. I just don't deal in that world.
Okay, and outdoor, do you think that you would have to intercrop it, or can you set like a perimeter around your
I think that it depends on what pest you're fighting. If you're fighting whiteflies, I think putting a perimeter out. This technology with the whitefly was used by Disney at Epcot before they even invented imidacloprid and some of the systemics. And we had banker plants around the outside, and the staff would go and grab a piece of a banker papaya leaf and take it into the show and stick it into the flower gardens and let the natural enemies emerge from that piece of leaf. And so that would protect them from whiteflies. Because they don't want to spray those plants because they have little kids crawling around through the flowers and eating them, and who knows what they do with them. But again, that's one that was used by Disney or Epcot.
Awesome. Great questions. Yeah?
Let's wrap it up. All right. Last question, Sydney.
Sydney with Munza Empire. For the light issue we were talking about, on the field, do you know what's the spread it would be for?
You'll have to see what the spread of the light is from whatever particular light you get, but I've been buying the inexpensive solar single and double head solar lights off of Amazon. I pay anywhere between $40 and $80 depending on what the sale is. They make sure that they put out 6,000 lumens, and I get about a 30-foot canopy. If I put it up about 10 feet, I got about a 30-foot radius. And you can definitely tell the edge. I mean, I have plants that are half veg, half flower. I mean, it will edge remarkably. So thank you all very much for your attention during this panel. We appreciate it greatly. If you have any more questions for the rest of the panelists, we'll be around for the rest of the show and be glad to talk with anybody.
Thank you, panel.
Thank you.
We're going on break real quick, and then we're coming back for one last session. Jeff Green is going to be here talking about selling products on Amazon. I know, Jeff, you weren't here yesterday. We did talk a little bit about Amazon. Charles brought up a good comment on Amazon that I'm sure you'll be interested in. And then Josh Lindley is going to come in and talk about how to get a license to grow and also the hemp business. He's got some business aspects for us.